Hey, Dr. Romano, physics again. Looks like that little man's getting ready to jump off the building up there. What's happening?
I want to go over a question with you today on free fall. And I'm going to show you some good tricks that my professor in college taught me. One of the most essential things in physics is to draw a picture of the scenario. You don't have to be a good artist, but you have to draw a rough sketch. So let's take a look. We're going to take the moon, and we're going to have an astronaut at the top of a crater, and he's going to throw down a rock. And it's going to take 6 seconds to hit the bottom, and the distance from the top to the bottom of the crater is 100 meters. So I think you could draw a picture. I like to draw stick figures. I'm not a good artist. There's the 100-meter crater. There's the astronaut. He throws the rock down. He drops it, I should say. Whenever someone says drops in physics, it means the initial velocity was 0. What I want to do is to find the acceleration due to gravity. We all know on Earth it's negative 9.8 meters per second squared, but that's not true if you're on the moon. The first thing we're going to do is we're going to draw the distance formula and write it down. S is the distance, is 1/2 at squared plus v initial t. What I'm going to do is start the problem where the ball is. So I draw an xy axis. This is a little trick my professor always showed me. And as you can see, the distance is underneath me. So it's going to be negative 100. So I plug in negative 100. We don't know the A. The time was 6 seconds and we square it. It started from rest. That's why this is a 0. So you're going to end up solving and you get a negative number and we get negative 5.56 meters per second squared. The negative sign simply means the acceleration is going downward. All right, that's easy enough. We now know what the acceleration on this moon was. What would be the impact velocity? Well, the acceleration formula works wonderful. Acceleration is final velocity minus the initial over time. We already found the acceleration to be negative 5.56. We know the time. We don't know the final speed at the bottom right before impact, and we know the initial was 0. Cross multiplying, again, gives me a negative number, which just means it's going downward. Don't forget, velocity and acceleration are vectors, which means they have magnitude and direction. All right, we got minus 33.4 meters per second on that. Notice the units are meters per second, and acceleration is in meters per second squared. Part C, if the mass of the rock was 2 kilograms on Earth, find the mass on the moon. Never forget, the mass is how much molecules and atoms make up a substance. It never changes with distance. So if you graphed it, mass versus distance, the mass stays the same. The weight changes of an object, but never the mass. Always a question on an exam. Mass never changes. So the answer would be 2 kilograms, of course. Does not change. All right, I hope this helps on a very, very illustrative problem on motion in free fall. When you go to the Physics Destroyer, you'll see a whole bunch more.
Hey, Dr. Romano, isn't it funny? I thought that little man was going to jump. I didn't know he was an astronaut just throwing a rock.
No, the little man didn't jump. Just the rock was thrown. Good day to you.
Oh, boy, I got that. Wow, Dr. Romano, you sure made this stuff fun and easy. Thank you, sir. Good day to you.